Hello, everyone. How are you doing today? Welcome to day 24. Damn. Last day of third week. I can't believe we made it. Oh, much better. Welcome, everyone, to this live stream where we are showing up every single day of January to build a little bit every single day. While my camera goes like, nope, I don't want to. My camera's like, not today. Today, I just want to rest. Who are you and what did you do to Shruti? She's dead. It's me. It's me, not Shruti. How are you, Hunar? Did you start streaming already? Um, I want to see your stream. So if you have already started streaming, let me know. Okay, today we actually don't have a lot of time because it's freaking Friday and I want to get out of here so I can indulge myself. You look so different with the pony, right? I almost did not show up like this, and I was like, check your general chat. And I was like, screw this is real. Let's keep it real. General chat. What are you showing me? Well, I done goofed up. Walked 15 minutes to my nearest Starbucks. Drive-thru is open, but walking is closed for meeting. Oh, I decided to walk additional 35 minutes to the next Starbucks, get my coffee, walk 50 minutes back to home. Oh my goodness. I burnt the double the daily target of calories today. Well, good for you. Always a silver lining. My overall fitness is definitely improving because before I would have been done for the day if I did this. Now I just need a short break and I'll be working on something today. Won't be streaming today. Gotcha. Okay. Does anybody know why continuity camera sometimes pauses and restarts? I thought it would be the battery, but it's not. Honor, I hope you're having a better day now. 50 minutes of walk in this cold sounds painful. So, like I said, today we're not gonna waste too much time. We're gonna get right into it. So let me open my code editor. And bro, you're like, check, it could be overheating. Knock knock. Who's there? No, it's not overheating, and thankfully. But it's okay. I'll switch to the other camera. All right, let me get my code editor started. I almost didn't show up today because last night, as you know, I had been streaming until 12:30 my time, and I went to bed at 3 a.m. this morning. No, 4 a.m. this morning. And then woke up at 8 a.m. to record a podcast. So I feel dead. All right, get my code editor running. I'm gonna share my screen. New window, localhost. Okay. Visual Studio Code. I went to bed at 3 a.m. Oh, so a Tuesday for me. Tuesday for you? Why do you go to bed at 3 a.m. on a Tuesday? Alright, I'm gonna share my screen. Wait, I thought I fixed this. Okay, let's move this here. And then move this here. How about that? My typical sleep schedule is 2 to 3 sleep in and 9:30 wake up. That's kind of like mine too. I sleep pretty late in the night. But most days I'm not this exhausted. But I actually wake up much later than that though, to be honest. Alright, where are we? Alice. Okay, file. Open recent. Learning AI. Alright, what do we have in store for today? So we want to put in the database and create an index, which is what we were trying to do on January 22nd, and then perform vector similarity search. So what we're going to do today is end at 6, which means we have a little over 30 minutes. So we're going to copy this out, move this here, and this is why we built... What are you crazy? And then this is what we're going to do today. Put in DB. And yesterday we did CSS. What's new in 2024? Oh, also, if you work in corporate life, I would suggest that you make a to-do list like this and have an idea of what you did. And this will be super helpful when it comes time for promotions. Kind of like a list of kind of like a win list. So today we're gonna put in DB, create index. Alrighty. So if I go back to running my server, npm run den, and then npm run server. Oh wait, I don't have music going. I was like, why does this sound so boring? Besides the fact that I am dead. Node server.js. Go. Close Discord. Close this. Close this. Avoid distractions. And reload. What are snacking? Move the camera up a tad because one of the alerts is hidden. One of the alerts. Oh, I've blocked that alert. But I'll move it here. I don't have any alert there. I got some pumpkin seeds and my 7 shots of espresso. You're crazy. What are we snacking on today? Nothing. We're just drinking water today. Okay. As always, here's a demo of this app for those of you who are new. We are building a search platform for searching properties in Seattle. So imagine that you're looking for a house in Seattle and you don't want to enter these random fields in Zillow or Redfin. You can actually look for a property by simply typing in English language. So you can write looking for a 3-bedroom house in Seattle in the starting range of this to this. Now what happens here is after I hit search, I send this text over to the OpenAI LLM, and that LLM then parses this English language text into JSON, which I then send over to my Zillow API. And if I hit search, you will see that now I will see a list of properties that match the description that I wrote, which is here and here. Wait, that does not match. Ooh, look at this beautiful house. What I am building now is a recommendation engine. So let's say that I like a house like this, which is looking like an A-frame, not A-frame, but like 2-level house, big windows, a cute looking front yard. There are certain properties of this house, or like certain characteristics of this house that I like. And if I like a house like this, I want the LLM to recommend me similar houses. You'll notice that it has 3 bedrooms and 4 bathrooms, and it is 2,890,000. So pretty expensive. But if I click on like, what I want to happen in the background is that I want to see similar properties like this. And what happens in the background is that I'm saving this property in my database with a preference of true, meaning that this is the kind of property that I want to see, and I would like to see more services like this, more properties like this. At which point my recommendation engine is going to kick in and recommend me similar properties. So today we're going to build part of that recommendation engine. So far, what we've done is we've found a database that is compatible with vector data, which is convex. And we're going to store our vector data in convex. We're going to create vector embeddings for properties. We have properties currently in JSON, and we are going to format that into, we're going to create vector embeddings from it. We already did that on January 20, and then create vector embeddings for JSON, which is something that we've already done. Now this is what we're doing today. Create database, a table in database, and create a schema and define a vector index. This is where we stopped on 22nd. So we are going to do that today. Create a table in database and create a schema. And then define a vector index. So let's go into this LLM file that we were building. And then the schema actually comes from Convex, which is something that we are, which is the database that we're using. So we're going to open up this documentation. For open Convex schema. And once you've defined what your data should look like, at that point, you also have to define what tables we have. Okay, so we've defined the schema. Where are we? Where did my file go? Schema.js. Okay, so I've defined this table, the property table. We only need one table, at least for now. So we're going to keep that as is. Then the validators is this stuff, which we already wrote. What else? It gives you copyright-free music and directly hooks into your stream, including showing the song. You know, I used to have that hooked up before. I forget which widget it was, but I had that hooked into my stream before. But it was for OBS, so I haven't set that up for Streamlabs. I did not want to set it up this time because I don't know why I didn't set it up this time. I think I just didn't have the time to. But I could do that for the future, for the next season, season 2. For season 2, I will also be using the overlay that you had recommended, Hunar. The lo-fi one. That was really cool. Uh, Bhide Svelte. This is interesting to learn. Hello, Bhide. Bhide? I don't know how to say this. Bhide? Sorry if I butchered your name. How are you doing? This is interesting to learn. Yes, it is. I mean, you get a part of ultra use and abuse. Um, yeah. How do you like ultra so far? I am really liking ultra. Oh wait, ultra has this tip settings. Maybe later. Right, music. I have to remind myself to like stay focused today because I have such short amount of time today. But I want to get at least something done before we head out. Okay, excuse me. Play my music. What were we doing? Oh, right, the index. So after we've done the schema, I think the next part is to make the index. Ooh, what? Huh? You can do this within the dashboard itself? Okay, let's log into Convex. I mostly use Svelte framework for building website. That is new to me. Vector embedding stuff, learning from you. Oh, cool. I'm glad then that you hopped into the stream. I think Svelte is the web part of this, but vector embeddings is how you add the functionality. So vector embeddings is how you generate a similarity search, how you do a similarity search, which is how similar is one property to another property. Okay, so I've got property here. Follow a quick start guide. Ooh, might as well. Okay, so React is what I'm using. And then they have TanStack start as well. I don't have TanStack start today, but maybe later. Create a React app, install Convex client. Okay, let's do this. npm install Convex. I don't think I've done that yet. Add a new terminal. npm install Convex, npx. This will prompt you to log in with GitHub, create a project, save a production deployment materials. This will also create a Convex folder for you to write your backend API functions in. Oh, I already have this though. Let's see. npx convex dev. Create sample data in your database. In a new terminal window, create a sample data.jsnl file with some sample data. Add the sample data to your database. Define a schema. Add a new schema in Convex with a description of your data. This will declare the types, blah, 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 blah. Remove this line from the ESLint RC to allow type checking strictness. Expose a database query. Add a new this with a query function that loads the data. Create a new project. Create an existing project. Monster kill. Property listing. It already knows that I have. Oh, because I'm signed in to GitHub. That's super neat. Exporting a query function from this declares an API. Name this is this. Connect the app to your backend. Source man create Convex React client. That's how we gotta connect. And then you go like Convex provider. You got your client here, and then you can just use the use query function to get your data. So super easy, but one thing that we missed was creating a vector index. So let's look into that. They said that you can create it here in the dashboard. Where is that? Oh, click on the little thingy. So click on the thingy, schema indexes. Okay. This table has no indexes. It does have a schema. That's nice. Learn more about indexes. We need a vector index. A name must be unique. Order list of fields. The specify list on nested document. Right channel. Write your convex functions in convex. URL as v convex to m.this. Okay, convex functions are ready. Sweet. So now I gotta do an index, and then you can do index like this, but how do you define a vector index? Right now I need to go at 7 a.m. in India. Oh, okay, no problem. Thank you for stopping in. I think the documentation I was on yesterday or day before yesterday was actually much better. So I'm trying to find that. I believe it was in their vector embeddings area. AI and search. Vector search. Vector search app defining vector indexes. Okay. To add a vector index onto a table, use the vector index method on your table schema. That's what we need. Okay, so you've got this. Vector field string. Okay, this is where it is. So you've got the table, and then you define it by embedding. What is this embedding? By embedding. Use the vector index method on your tables. In schema, every vector has a unique name with a definition with vector field string. Oh, that is the name of the field indexed for vector search. That is embedding. Oh, that's just the name. You can define whatever name you want. So let's go ahead and do this. Define table. This is gonna be on okay, so that's gonna be on the vector index, and then I will give it by oh, I didn't add embeddings here. Should I even add my embedding? I probably need to, right? How am I otherwise gonna know how to do a search on it? Wait, this is a v float. Okay, and this is gonna be by embedding. Then the vector field is embedding for me. Dimensions. I don't really know its dimensions. 1536 for OpenAI. Fixed size of the vectors index. If you're using embeddings, the dimension should match the size of embeddings. 1536 for OpenAI. Sweet. Dimension 1536. Filter fields. The names of additional fields that are indexed for fast filtering within your vector index. Okay. Filter fields for me would be preference. Actually, filter fields for me is going to be nice to haves, which I don't even have right now. Oh, you can provide multiple things. I'm going to give nice to haves because that's kind of what differentiates one property from another property. And then I don't have nice to haves here, so I want to add that. Okay. You can specify vector and filter fields on nested documents by using a dot separated path like this. Okay, that is our schema. Let's commit the schema. Missing dimensions field. What field? Okay. Missing dimensions field. Oh, dimensions. Okay. Okay, nice. We have a vector index right here. So fast. So cool. All right, the next step is to have, where was that? Close this. Oh, running vector search. Oh, create an action. Anyways, I have to go. Have fun on the stream. Thank you, Hunar. Thanks for dropping by. I will see you later. Have a great weekend. Generate a vector from provided input. Example using OpenAI. Use context.vector search to fetch. Oh, what is CTX? To fetch the IDs of similar documents. Load the desired information for the documents. Here's an example of the first two steps for searching for similar French foods based on description. What kind of actions are these convex actions? Actions can call third-party services to do things such as processing a payment with Stripe. They can be done in JavaScript's environment. Oh, we were gonna commit this. Adding schema with vector index. Okay. Then we are gonna create an action. Actions follow the same naming rules as queries. I think we have a folder here called convex. Okay. Okay, so let's import an action. We have to actually create a function within convex called functions. So let's do that. To declare an action in convex, you use the action constructor function, pass it an object with handler function which performs an action. So let's go ahead and do that. We're gonna call it, I don't know, database functions. Random guy. Hey random guy, how are you? Just woke up here in India. It's pretty cold here around Lucknow. It's pretty cold here too. It is actually -2 degrees here. Before you go, where did you post that before after post? I saw it earlier. I deleted it. I was like, not feeling it. Deleted it. But I can send it to you on Instagram. So we're gonna call it vector functions. Let's call it vector functions.js because we don't have TypeScript. All right, so we want to import action from generated/server. Oh wow, look at that. So to declare an action in Convex, you use the action constructor function, which is what they're doing here. And then you pass it an object with a handler function which performs the action. Implementation goes here. Option return a value, return true. Unlike a query, an action can but does not have to return a value. Action arguments and responses follow the same rules and limitations. Oh, these are the arguments that it takes, the action takes, and the arguments is handler is something that it returns. Action constructor enables the first argument of the handler function is reserved for the action context. The action constructor enables interacting with the database and other convex features by passing an action context object to the handler function as the first argument. Blah 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 blah. Which part of the action context is used depends on what your action needs to do. To read data from the database, use the run query field and call a query that performs the read. So you got internal.myfunctions.read data. That's starting to look very kind of verbose now. You write data to the database reading the run mutation field and call a mutation that performs the write. Okay. Wow, already sleepy. It was so memeable. I was gonna say my auntie Shruti. I know I aged like 10 years in that photo. You make me feel bad though. Oh, so if you perform my action, you, to call an action, you just use like the use action hook, and then you perform my action by calling in on your handle clicks, which is easy to do actually. Oh, hey, Anis. Morning, everyone. Evening for me. I am 30 next year, not like I am not getting there either. Get out of here. Okay, I think something that we're missing is what happens. Use context.vector search to fetch the IDs of similar documents. Okay, this is what we were missing. So basically, you create an action, and then arguments is the description query. What's the description query? Generate an embedding from your favorite third-party API, which I've already got. Then search for similar foods. You got context.vector search, foods by embedding. What is foods? If we go back, what is vector search taken? I think that's the table name. Right, that's the table name. So it takes in the table name, the embedding category or the vector index that you want to use. Then vector is the embedding, which you get from OpenAI. Limit, I don't know why they added a limit. Filter, okay. Example of vector first step can be found here. Focusing on the second step, the vector search API takes in the table name, the index name, and finally a vector search query object describing the search. The object has vector array limit. Oh, this is optional. The number of results to get back. Okay, sweet. I think for me, I'm going to generate like 3 or 4. I always forget that there is 13 hours of time difference. Yeah. So when it's like super early morning for you, it's almost time for me to get off work. When it's time for you to get to work, it's time for me to get off work. Okay, I think we're doing pretty well. So let's keep going. We had an action. We haven't defined this action. So let's go ahead and define this action. Generate a vector from a provided input. Let's do this. So we got import v from convex values, export, save similar properties. That's what I'm going to call this. Properties equals action. And then what is this? We don't need this, bro. Action. Look at that. Neat. Let's just make sure that this is correct, okay? Arguments embedding v.array v.float64. Oh, okay. This is correct because we have to provide the embedding. Oh, we can actually just provide it a JSON. Let's do that. So we're gonna provide a we're gonna get a property, and then we're gonna get this from. Do we have a v.object? There you go. v.object. Because our property is in JSON, so that's why. And then in handler, we've got this is arguments dot property. So this is argument, and then results is at this point I need to call OpenAI to get embeddings, which is something that we've already done in LLM, so I just need to call it. And I'm gonna add to do here. And then const results is context.vector search. In the table property, is it called property or is it called property listings? Property, cool. By embedding, vector is the embedding that I get from, and I'm gonna give it a blank array. Limit is, I'm just gonna ask for like 5, okay? Filter, do I need a filter? Oh, preference, no, I don't need a filter. Num results, I don't need that. That's it. That's all I need to do a vector search. Pretty simple actually. This is literally all the vector search I need to do. Perform a vector search by using the liked property. Liked property fetches embeddings from OpenAI for a particular property and sends and calls convex action and calls convex vector search to perform a similarity search. One thing that I noticed is that a lot of the distance calculation is hidden by this function vector search. So I want to read this function to see what this function does. So it says run a vector search on the given table and index, the name of the table to query, the name of the vector index containing the query, number of results. So what it does is, if I undo this vector search, the default arguments type for convex query, mutation or action functions. Convex functions always take arguments, maps. Where is the, what is it, what a, oh, this is, okay, before I read that, oh wait, I could just read it here. On the given table and index, table name, server registration. This is just, oh wait, I have the implementation here. So I'm looking for vector search in where's the impl? Vector search. Wow, this is a lot of code. I'm gonna make a new file. Bro, new file. So let's see what it does. Export function, setup action vector search, table name, index name, query. First it validates, if query.vector, throw error, return vector query impl. It's written in Java. Oh, TypeScript. It looks like Java. Okay, this dot state is type preparing, query index name, collect. So you got this dot state dot query, type consumed, perform async syscall 1.0 actions vector search, serialize vector query. Hold on, what do you do? Perform async syscall, that comes from syscall. Oh, file is not found. Collect, return results. Okay, let's look it in the database. If type of convex is undefined, convex.async call, results is convex.async syscall, which is gonna be here. No. Where is this function? Okay, 4, I finished this, don't save. I'm gonna commit this code. Vector search. Git push. That wasn't too hard, was it? I think all of the magic was actually done by Convex itself. So I literally just had to call the functions, create embeddings, and that was it. One thing that I haven't done so far is actually wire up the embeddings, which are in my LLM file. So I'm gonna bring them over. In my beautiful looking LLM file, I have probably this thing called embeddings. There. I don't think I have a new file for this. Okay. Think a little bit of refactor is needed because I have this data here which needs to go, and I don't need this. Stringified data, this needs to go. This needs to become its own. Oh, hold on. So this is all I need. can just move it to a vector function, call it here, and embeddings becomes this. And then the only argument that we need is property that comes to this function, this use action, this action from the UI itself. So this data.map that I was doing is actually just going to be the property. So that's all I need to do. I just need to JSON stringify this property, and I can just be like property. And then this says embed documents. I actually don't have this as a document, but I can use embed query and then send it the stringified property. Okay, stringified property, da da da. Yo, let me do this. Okay, and then results is what I need to send back. I think I'm missing one. Oh, this is too many. Cool. And then if I add this, git add dot git commit, adding embeddings to vector search git push. And now if I do a quick test, because I don't have property, so I'm gonna give it like a random ass property, zip ID. I'm gonna call like I don't know, like there you go. Cool, let's try this. Let's give it a shot. Vector functions. I'm gonna call this from LLM. Export this similar properties. But wait, I can't call it yet unless if I have use action hooked up. And this is where we'll take a pause. How goes the project tonight? It is going awesome, actually. Todd, hello, welcome back. Actually, let me show you. I'm gonna update the to-do because only in 20 minutes we made a ton of progress. So here's what we are doing today. This is what we did yesterday. Put in DB, create index. Let's cut this out. Create index, yes. Create table and database, create schema, yes. Define a vector index, yes. Fetch similarity JSON object. Fetch similarity properties from Zillow API. JSON object from similarity search. This is something that, this is what convex vector search does for us. So then on Monday, this is where we're going to continue. I'm actually going to move this up here because we already did this. On Monday, we're going to put in DB, put property in DB because right now we have no properties in our convex DB. Then we're going to generate similar properties, which basically just means doing a test. Doing a test of the code so far. And then what do you want? To do item status. Accept. Accept. And what else? Put property in convex DB, generate similarity properties, and then fetch similar properties. If we can, we'll do it on 27th as well. But I think this is a good plan. I can't believe we were able to get like all of the code written so far. So, okay, git commit, updating plan, git push. And that's it. Good for you. Thank you. I know. Was able to get so much done. Today was a short stream, so I'm going to have to say goodbye right now. Why did you choose Convex for your DB? I chose Convex because the database that I was using earlier was Directors, which is where my properties are currently. It doesn't have vector data. It cannot hold vector data. So I had to move away from a database. And then I was looking at other databases. I did a analysis of some databases that are popular, like Terso, Cassandra at the time as well, and Convex. And it turns out that Convex actually has a function called context.vector search, which will let you do it. But what I like is that there is no need to write SQL. It's also familiar to me, free for me, and the way to embed Convex within your database or within your UI is super easy, and it was a lot easier than Terso. So it was a good choice. Of course, there's other databases as well, like AstraDB. I didn't actually end up looking into AstraDB at the day, but because Convex is something that I'm pretty familiar with, but also is easily pluggable into your UI, so you don't have to write a lot of SQL. That was the direction I chose. XPro. Hello, XPro. How are you? Folks, today's stream is pretty short because I need to head out right now, and I just wanted to say thank you so much for coming to today's stream. I hope you had fun learning about LLM. We are so close to getting this done. We are almost I think we are 85% done. We only have a little bit left, which is actually just like testing right now. Okay, not testing. We need to test what we wrote today. Come back and fetch similar properties from Zillow API, which is everything that we're going to do next week. Render similar properties on the page. And that's basically it. And after this, we're going to have a working recommendation engine. I can't believe it. Oh my God. I can't believe it was so easy to do this. Okay, I wouldn't say easy, but it was not that difficult to do this. I'm pretty proud of us. I'm so glad that we've been here 24 days of 30 days so far, and I will see you on Monday. Remember, this is a 30-day live stream, which means that we show up here every single day, every single weekday, because rest is important, and do a little bit every day. We don't know it all, but we know some things, and some things are good enough to get us moving and show some progress. With that, I'm going to say goodbye for now. I will see you on Monday at 5 p.m. PST. I'm in Pacific time zone. I will see you then, and until then, if you want to check out the GitHub repo, I will share that in the comments. And if you have any questions, send me a DM on Discord. The Discord link is here. Up there. But thank you folks so much for joining me. I will see you soon on Monday. Have a beautiful weekend ahead. Take rest, enjoy some time off, and don't forget, you are smarter and stronger than you think. If you have gotten here so far, you have the courage and the dedication and the skills to take you 10 more steps forward as well. With that, have a beautiful Friday, evening, or Saturday morning, wherever you are. Bye, folks.